Let's say you are seated peacefully in the exam, minding your own business, and they ask you to solve for x for 6 marks in this case. So what are you going to say? Now, the first thing you realize is that the variable x is in the exponent. So as a result, this is an exponential equation. The first thing you must do here is to make sure that the 9 is written in exponential form to base 3. So it's just going to be 3 squared, right? So if you have 3 squared, which is further raised to the x, you can choose to write this as 3 to the 2x. Then you say you have 26 times 3 to the x, and this is set equal to 27. Now you have to observe. So here you realize the coefficient of x is 2, but here the coefficient of x is 1, and the third term does not have a variable x. It's just a constant. So every time you see this situation, you must know that you are dealing with a quadratic equation. But in order for you to see it clearly that it's a quadratic equation, instead of me writing 3 to the 2x, I'm going to write it as 3 to the x, which is all squared. I didn't change anything. So remember, we said 9 is 3 squared, which is raised to the x. If you expand this, you get 3 to the 2x. The same holds if you have 3 to the x, which is all squared. Sorry about that. If you expand this, you still get 3 to the 2x. So it's exactly the same thing. The difference is the position of the exponents. So remember, the whole point of me writing it this way is so that you see it clearly. And I'm going to write this in standard form. Standard form meaning I take 27 to the left. So here you can see that this 3 to the x is raised to the power 1. It's like you are having x squared minus 26x minus 27. It's almost the same thing. But if you look at it, it's a little bit complicated, right? So in order for us to simplify it, we are going to use what we call the K substitution method. So what do I mean by that? We have to let K to be 3 to the x. So in other words, every time you see 3 to the x, you see K. So you'll have K squared minus 26K minus 27. And this is equal to 0. So you have simplified it to the familiar form of a quadratic equation. Then from this point, in order to solve for K, before we can solve for X, we have to factorize. And we know that we factorize by opening 2 brackets. So factors of K squared, it's K and K. Factors of 27 that add up to 26. It can only be 27 and 1. The bigger number takes the sign of the middle term. The 1 has to be positive. So that negative 27 plus 1, it's negative 26. And negative 27 times 1, it's negative 27. Then from this point, you say K minus 27 equals 0, meaning K equals 27, or K plus 1 equals 0, meaning K equals negative 1. Then you replace K with what it is in terms of X. So you say, every time you see K, you actually see 3 to the X. And this is equal to 27. Then you can say, or 3 to the x equals -1. Now this one we can see it's a no solution. Why? Because we can't write -1 to base 3. Do you see that? If it was just +1, we can say it's 3 to the power 0. But seeing how there's a negative we can't do anything. So there's no solution here. But now in order for us to solve for x here, we have to make sure that 27 is written in exponential form to base 3. So now the bases are the same, then the exponents are bound to be the same as well. And this is your nice value of x. Did you see that? Well, in case you didn't, let's do another question. Well, it's not similar to this one, but the concept is the same. You just need to understand the concept, guys. If you do, you can move mountains, I assure you. So let's see this. It's 6 marks as well. Solve for x. So here they say you have 2 exponent 2x plus 1. And then you say plus 15 times 2 to the x. And this is equal to 8. So we need to solve for x. Yeah, this one is much better. Right. Now, before we can do anything, we have to observe. So here we realize the coefficient of x is 2, but the coefficient of x here is 1. And the third term, which is 8, it doesn't have a variable. Do you see that? So by now we understand this is a quadratic equation. But in order for us to make it a quadratic equation, we have to start first by reversing the first law for the first term. So we say before it became this, it was once 2 to the 2x times 2 to the power 1. And then you say, this is 15 times 2 to the x. So let's take 8 to the left so that it becomes negative. Then I want us to write it in a way that you can see clearly. So we'll take the 2 and put it here. Instead of us having 2 to the 2x, we write it as 2 to the x, which is all squared. Do you see that? And then you say plus 15 times 2 to the x, and then you say minus 8 equals 0. Then here we can see clearly the 2 to the x is squared, but here it's raised to the power 1. So indeed, this is a quadratic equation. But in order for us to take it to the form we know, we have to use the K substitution method once again. So let's allow K to be 2 to the x. So this means where I see 2 to the x, I actually see K. So you'll have 15K, and then you say minus 8. This is equal to 0. Now, at this point, you realize this is an advanced quadratic equation. So in order for us to factorize this, we can't jump to 2 brackets right away. So we have to go to our small table in order for us to gather the factors. So let's go to that table. So what are we doing in this table? We are going to list factors of the first term, meaning ways in which you can write the first term, as well as the factors of the last term. So 2k squared, we can only write it as 2k times k. But 8, we can write it as 8 times 1. We can also write it as 4 times 2. So we have to put 2k and k once again. So here we are looking for a combination of factors such that after saying something times something and something times something, if we add or subtract those two somethings, like the product of those two somethings, the answer must be 15k. What am I saying? If you say 2k times 8, you get 16k. And if you say k times 1, you get k. Can you see that 16k minus k, it's going to be 15k. So meaning the first combination of factors is ideal for us to use. But let's test the second combination. If you say 2k times 4, you get 8k. If you say k times 2, you get 2k. There is no possibility of us adding or subtracting these two such that they'll give us 15. So meaning they are not ideal for us to use. So since we know this is the combination of factors we must use, then how do we go about it? Well, you have to take 2k and then you say 2k multiplied by 8 gives me 16k. This is how you'll write it. Then you come and say k multiplied by 1 will just give me k. Then you say, what is the sign of 16k and the sign of k? So that if I add these two, I get 15, positive 15. Then you can see that k has to be positive and negative k has to be negative. Now, from this point, we can get factors that factorize this quadratic equation. So which factors are those? Well, this is the first factor, and this is the second factor. So you say it's 2k and 1, and then here you say k and 8. Now, where do we get the signs of these factors? This is where we get the signs. So it means the first factor will be negative. The second factor will be positive. From this point, you say this is equal to 0. Then you apply your zero factor law, meaning you say 2k minus 1 equals 0. Then you divide both sides by 2. Then you realize your k will be half for this one. And for this one, your k will be negative 8. But what is k? Well, k is 2 to the power x. And this is equal to half. But this is an exponential equation. And in order for you to solve for it, you have to make sure that the bases are the same. So you write half in negative exponential form. It's 2 to the negative 1. Well, the bases are now the same. So then we equate the exponents. Then you come to the second part, you say k is actually 2 to the x, which is equal to negative 8. But then you can see that we can't get negative 8 for any value of x that we substitute here. So because of that, unfortunately, we can't solve this. So there is no solution for this one. And then you should be happy and jumping about with this one.